Okay, so let's begin our SQL class. In front of you, there is a Costco receipt. You go to Costco, I'm pretty sure. So what you see on the receipt is very important because every single item on this receipt means something, and it goes to a certain table and certain column in a relational database. So basically, every business in the United States has some kind of database where it keeps information about all the users, all the products, services, and so on. So every little thing is documented somewhere. And for that, we have database with tables and columns. So Costco warehouse, you see that it says El Camino number 475. So that will go to a table called store, right? That makes sense. And it will go to a column called location ID, and location ID will be 475, and locational name will probably be El Camino.
Okay.
And then there will be an address, which is 1600 El Camino Real, so San Francisco, California. Next, we have a customer ID, which in Costco is member number 11, and there is a very low number. Costco is everywhere in the United States. I'm pretty sure they have like gazillions of customers. So, yeah. And then there are products, sweet potato, which is a product name. Product ID of a sweet potato is 651 242, I would assume. And then there is a price, which is $10.99. So all of this information, so the customer ID would go to a customer table, obviously, and product information will go to a product table. And at the end of the receipt, we usually have something about transaction time, transaction ID. In this case, this transaction was in 2019 at 12:05, and transaction number is also very long, right here, 475 something, very long number. Then we have an employee ID. It looks like it's operator number 107, and the name is Omar Z. So that would be an employee name. So probably Z is the first letter of the last name of the person. This information would go to employee table. Is this kind of clear?
Yeah, makes sense.
Okay, so now we're gonna go to another screen because I'm gonna show you how it's gonna look. As you can imagine, I never worked for Costco store, but I would imagine, because it's very predictable, every single store in the United States has something similar. Every store has customer table. Every store has product table. Every store has employee table, and every store has, if there are more than one stores, let's say it's a chain, there would be a store table with different location IDs of that chain. So, and whenever something, the sale happens, it's a transaction. So it would be a transaction table. So now I will tell you a little bit about this colors. Why do I have everything in yellow and green? So so this is a concept of relational database. Why is it called relational? Is because every single table in a database is related to another table. So basically they're all connected somehow. Okay, and they're connected. So each table is supposed to have a primary key. What does it mean, a primary key? It just means that there couldn't be any duplicates. For example, let's look at the customer table, right? My name is Tatiana Kurzner, and it's possible that somewhere in the world there is another Tatiana Kurzner, which is possible. However, even if Costco has several Tatiana Kurzners, we all have a different customer ID because we're all different. So that's why you cannot have a primary key, which is unique, by a name. You have to have it by a number. That's why usually primary key is a number, because it has to be unique. Other things, other attributes are repetitive, like names of people and so on. There are many people who live under the same address, so you cannot have those attributes as a unique identification. Therefore, each table has a primary key, which unique set of numbers for each particular identifier, like for a person, like for me personally, like Tatiana Kirchner, who lives in San Francisco. So that's a primary key. It means there are no duplicates, because if there is a duplicate, it means that referential integrity is no longer valid, and it cannot be a good relational database. So you cannot have duplicates in any of the tables. That's a must. Okay, so what is this all green stuff? This green stuff is foreign key, which is not the main key, but still an identifier which is needed to relate one table to another table. For example, customer table is related to transaction table, and customer ID is a primary key in a customer table and a foreign key in a transaction table. So this is a very important concept, because somehow we have information about everything that's going on in Costco business, and every single element of that business needs to be somewhere. Okay, so it's all in different tables, and all these tables have to be some kind of connected with each other. So you would say, oh, what if I need to get some information from product ID and a location ID, right? Because I want to know how many products were sold in a particular store number. In this case, Costco number 475. So, and you would say, oh, there's no connection. Look, there's no line. They're not connected, right? Product and stores are not connected. In this case, if you need information from product table and store table, you will need to drag in your query all other tables. You would need to get the product table. You would need to get transaction table. You will need to get employee table, and you will need to get store table in order to connect all of these puzzle pieces. Okay. And so this is a puzzle. You have a business question, right? Tell me how many things were sold in this store. Who was the best employee of the month? Whatever the question is, you need to have this diagram. So in a database, we called it EER diagram. And every business should provide you with this diagram. I mean, in the database, I'll show you how you can get it yourself in the MySQL database, but I don't think you might not have access to it, and it's easy to just ask. Just tell me, where's your database? Show me how all the tables are related so that I could create a query if you need to create that query, okay? Okay.
One clarifying question for the foreign key.
Yep.
What would be an example of that? Would be product ID or customer ID? What's the...
So for product ID, it's possible that, for example, product ID exists in transaction. You need product ID in transaction table. In this case, as you can see, this transaction table has everything, right? Almost everything you need, because for transaction, you need to grab everything. You need to know who was the customer, what product was sold, who sold the product, right? Which employee. So basically, location ID, right, is over here. Employee ID is over here. Customer ID is over here. So basically, every single primary key shows up as a foreign key somewhere.
Got it. Okay.
Okay?
Yeah.
All right. So let's move to another screen. Why MySQL? I usually show MySQL only because it's free. There's no other reason. This is my SQL workbench, which is the front end for my SQL database. There are many front end applications that you could use for the back end databases. Some of them, SQL Navigator, Toad, I'm sure there's tons of them, but it's not important because they all kind of look similar. What you usually see on this kind of applications, it's on the left, you will see databases. Look at this little thing. I have a career database, classic models, Costco. So this is just the Costco. We looked at the Costco database. So somebody creates those databases and then tables and then loads all the records. But some people who are just users of the database, they will never be creating those tables. They will be just querying them. Okay, so I think the purpose of today's discussion is just, lesson is to show you how to query, not how to create anything.
Yeah, I don't think any of the jobs that I'd be applying for would need to be creating them.
Mm-hmm.
Yeah.
Okay, so let's see. So Costco database, the one I showed you in Microsoft Excel, here they are: customer, employee, product, store, transaction. And if you want to see how the ER diagram looks like in actual database, right? We're going to go here. We're going to, I'll show you some steps. I don't think you need to know this just because they will probably not let you do this anyway, because it's more like an admin's kind of function. So, but the reason why I want to show it to you is that every database has it, okay? And that's important to know because it does exist. And I hope nobody will tell you that you're crazy, okay?
All right, sounds good.
Okay, so here we go. So here's our Costco database, the one I showed you in Microsoft Excel. Here it is in actual database, same thing, okay? Is your transaction table with your foreign keys, right? See that?
Okay.
Yeah, and
so if they didn't supply that to me, I could go and look it up basically.
Well, you would have to probably ask. I mean, the people who will give you access to the database, the DBAs, database administrators, they're the ones you can ask. Can you please send me an ER diagram? And you can see that it says EER diagram. It's an official name of this thing, okay? Okay, so let's go back. How do we query the table, okay? I want to show you the example of classic models database, just because it's, if you ever want to study SQL, that's probably what they're going to teach you. They're gonna show you classic models database, and it has many tables, but it's a pretty good size of a tables to show how the business operates. It has customers, employees, offices, orders, order details, payments, products, and product lines. So it's a more detailed kind of level of a business than I showed you at Costco, right?
Yeah.
Okay, so basic query, the basics of the basic. You want to know, you want to query one table, and you want to query table customers because it's the first one, right here. You can click over here and see all the columns, okay? Or if you want to see what's going on in this table, you can do the following. You can select star, which means select every single column from classic models database customers table.
Okay.
Okay. This is very important because if you select something, you need to know what you're selecting, and you're selecting first from the database dot table. Okay. Database dot table. Okay, let's run it. And there is usually a limit how many rows you can run. And I don't know why I put 50K. This is way too many rows and it's not needed. Usually 25 rows is enough for you to even see what's going on. Okay, I'll change it because it's ridiculous. Let's do 50. Okay. Okay, so you have action output. It showed you the action you selected. Star from classic models database dot customers table. 122 rows returned, meaning the entire table classic models dot customers has 122 rows. Let's look at it. So it gives you the summary, totals, and it gives you the details. So this is how it looks. So this is the entire table customers. Obviously, when you go work for a business, most likely you will have much bigger tables, right? The bigger the business, the bigger the tables. And big companies have millions of customers. So you will probably never write select star. You will probably select smaller number. And you can limit the number. In this window, you can write how many rows you want to see in the query. For large tables, don't do select star. Okay, so this is how our table customers looks like. You can, what usually people do, you want to check another table, you just drag the other table, right? And you delete whatever was before. And then you check what's going on with our employee table. Okay.
So when you say select star, that basically means everything that comes after the star is going to pull all the information from those fields?
It means selecting every single column. Star means a column, because if you want to find, okay, if you want to select a specific column, instead of star, you type the column name.
Okay.
So tell me, which column do you want to see from employees? Since we are right here, which column do you want to see? What do you want to see from this table? Here's the information. So on the left.
First name, extension, and office code.
First name, okay. I literally just drag it, you see, right?
Okay.
Put comma, extension, okay. And what was this third one?
Office, say emails. Okay, that makes sense.
So you highlighted and there's this lightning sign, but you actually can do query and then execute. So it's up to you how you want to do it. There are many ways, but I usually use this lightning shortcut. Okay, so here's your information, okay? Right, you're looking for someone, it's like, I know this guy, I need to know information about Jeff. I know his name is Jeff. Try to be very logical. You select on one line what you need, you select on one line. Second line would be from which table, database and table, and then you write your where clause. So here's your where clause. You're looking for Jeff, you have to write where. You always write where. And then you write where first name equals Jeff. In quotes.
Okay.
Here we go. And it always like this, it doesn't change. You can copy paste and change the column names, change the where clause, change the table names. This is your structure. This is it. This is your SQL. Okay. So it's very, very easy to query one table. The problem comes when you need to query two or more tables, right? Because you need ER diagram to understand how they are related, okay? And you know, people who know SQL really well, they know the shortcuts. They can figure out even without a map, without that diagram, how tables are related. But this is a little more deeper than probably you would need to know. So let's look at the table joins. Classic models, right? Let's look at the classic models. Well, first of all, if you ever need to know how many records in each table, because sometimes that information is important, right? How many records do we have? You type select count star from database.table. I usually, whenever I learn a new database, I look at every single table in that database and I do select count star. I create this record for myself. How many records are here? Just so that I know that if I ever need this information, I already have it. I don't have to do it again. I don't have to query anything again. I have it here. And if I want to join tables, I know that I will never get more than this number of records when I relate all the tables together, because this is the highest number of the biggest table.
Okay.
What people are afraid, those who use SQL, they're afraid to create duplicates, because it's easy to create duplicates if you do the wrong joins. The counts help, because if you know the counts of the biggest table, it helps you kind of know in a what area to expect the numbers. You know, if you have the biggest table of 2,996, you should never have the answers in millions. Okay, this means you're going to have duplicates. So always know your counts.
When you say the count, like what would be an example of a count in that six? So the count is 200, 2,906, 96.
Yeah.
What does that number represent?
It represents that this table has, that's the whole database. This is the whole database. It's called classic models. Order details is the table with the largest number of records. Therefore, if we query, we shouldn't get gazillion of records. We should probably, this is the largest number of records we should get, because that's how many, that's the biggest table. Otherwise, you will have the duplicates. I think it's a hard concept to understand right now. You need to practice to see how this works.
Yeah.
So let's look at the table joins. I will probably show you the theory first, because I think without theory, it would be hard to continue. Let's look at the theory. So table joins. Here's types of joins. There are 4 types of joins, and two of them never used. So this is a good thing. Okay. In theory, there are 4, but only these 2, inner and left, are used. Why right join is not used? Because it's identical like left, only that it's an opposite, and it confuses the hell out of people. That's why nobody in the right mind would use it. It's very confusing.
Okay.
Full outer join, it's very, very dangerous, because you can create gazillion of rows, and it's used in a very, very rare occasions by people who know what they're doing. So most people, I don't think people can even do this join, regular people. So anyway, all you need to know is what inner join is and left join. Let's look at the inner join. You join 2 tables, and only if there is similar information, the same information in both, it will show you the records in your output. Right? So only the records that are the same in both tables will be there. What is a left join? A left join, it means you join 2 tables. There will be all records from the left shown and only matching records from the right. So this is important to understand. And you would say, oh, I don't know when to use which one. And I'll tell you, I'll give you the examples. Let's try our very first query with a join. I will teach you the way to write table joins that you can use in any relational database. There are shortcuts that people use, for example, for Oracle database. And I started my career with the shortcuts. And let me tell you, don't learn them, because I went on and to another department where there was a SQL server, and it was like, oops, I can't write my queries anymore. What's going on? So I'm teaching you the correct way of writing queries, which will work in any database you use.
Okay.
Okay. And by the way, if you can see, there is a select from and then join. I put uppercase. Doesn't matter if this is uppercase or lowercase. Doesn't matter. Whatever you like, you can write. It actually doesn't matter even if you write uppercase anywhere. The only place where it matters, it's how the information is stored. The record itself matters. Whatever record is in the database, inside of the table, that's what matters if it's upper or lowercase. But everything else on the screen, how you write it, that doesn't matter.
Okay.
Okay. In this example, we join two tables. One of them is employees and one of them is offices. So what are we trying to do? We're trying to see all the information about employees and offices. In other words, I want to see each employee in each office. I want to see everybody, right? Basically.
Yeah.
Okay, so here's information. So since we write select star from first table, we're going to see everything from employees. And that information, let's see where employees table end. It's going to end with the job title. And we're going to see every single column up to a job title. Where's the job title? Here's job title. So this is the last column of employees table. And then we're going to see every single record from the office table. Okay, here it starts, office code. So we just ended one table and we started another table. Okay. So we see everything, every single column from both tables. Is this clear, kind of?
Yeah, yeah.
So the word join, all you do is you join, and there is this magic word on. You know, some people, when they write code for the first time, they actually draw. And it helps a lot because you draw employee table and you draw offices table, just like little squares. Mm-hmm. And then you write all the fields in one table and all the fields in other table and see how they are related.
It just helps you visualize it.
And this is, and you know how they're related. They're related by the office code. Both of these tables, employee and office, are related by office code. What I'm doing here is I'm calling it aliases. So I called offices office and employees employee. So this is a bit confusing. So this particular, I just grabbed the first query I saw, and my intention was in this query to show aliases that you can actually rename any table anything you want. And you know why people do that? They do that because sometimes you need to join 10 tables and you cannot carry along every single table name. It's way too many. It's like too complicated. It's too much visual stuff. A lot of people just call it ABC. So this would be table A, and this would be table B. And this would be table A, and this would be table B. Okay?
Okay.
So this is aliases. So I'm sorry I confused you because this particular example was about table aliases, but this is an example of a simple join, inner join, nothing complicated.
So when you're talking about joining the tables and you have the inner and the left join, like what would be an example of, like, for Costco or whatever, like how would you use that information? Like, why would you need to pull that information, and what could you do with it?
With Costco, usually you want to know who sold what product when. You want to know the best employee. You want to know how many items, for example, was sold in a day. Like today is November 12th. So
if you had an example, like, you know, you wanted to find out which employees were selling the most, and the two tables would be employees and who they were working for, like who was their manager or something like that, and you could join those two tables and get. I'm just trying to. Okay,
so manager information is in employee table.
Mm-hmm.
There is their manager as well, always. Okay, there's always reports to and some employee ID who that person reports to.
Mm-hmm.
The only person who doesn't report to anybody is a CEO. He or she or whatever, whoever is in that position will have a null under reports to column because there is nobody above. Okay.
Yeah.
So if you want to know who sold what and when, it's probably going to be employee table, product table, transaction table. If you need to know the name of the product.
Mm-hmm.
And that way you will, for transaction, you will say transactions only for that day, right? So you will know all the transactions for that employee and who that employee reports to. Okay. And then why do you need the product table is because transaction table has only product ID. You would need to join it with the product table to know the product name. Mm-hmm. Because for reporting, you need product name, right? You don't know what product ID number 111 means. You need the name. So that's why you need to join to product table.
Okay.
Okay. Okay, so let's look at another example of, so it doesn't matter if you write join or inner join. I'm gonna be, it's same thing. Join, inner join, database accepts both. Okay.
Okay.
It's just another example. This example is joining customers with employees. Okay, because and they are joined on employee number. Customer table has a sales rep employee number in this case. So sometimes the column names are different in this, like in this example. In the example above, office code is equals office code. This is simple. Anyone can join it, right? Because the same name in both tables. That's great, right? You can intuitively know, oh, these tables are related by office code. It's because it's the same name in both tables, right? Mm. Sometimes it's trickier. Like in this table is trickier because this is an employee number in employee table, but in a customer table, it's called sales rep employee number. Has another, I mean, it's similar, but it's not identical. See? Yeah. So you need to be more kind of creative to like search. Maybe it just looks like it, but not exactly the same name. Okay. So we just did inner join. Let's run this query. Inner join gives us 100 records. See, I always write on the top how many records I expect. This is very important. So there is 100 records right here. And what's important to know is that we'll do the left join. Watch sales rep employee number here. Okay, let's find that field, sales rep employee number. So when we do inner join, you can click on it, by the way. It's going to do descending, ascending order. Okay, see how it changes?
Yeah.
It just changes the order. So as you can see, there are no null records. Everything is, when you do the joins, no null records will be shown. However, you asked me for the situation, by the way, when you would use left join. So here's your situation right now. You're joining customer tables to the employee tables to see which customer doesn't have a sales rep on them. And I don't know why, but sometimes there are customers without a sales rep. And you can only do that with the left join. Why? Because this first table will always be your left table, meaning that you get every single record from customer table. And everything you can join from the right, from the employees table.
Mm-hmm.
So I would expect that you will see a lot more records in this next query because you're joining them together with the left join, because there are some customers that do not have sales rep. And let's look at it, okay? Sales rep employee number. Here we go. Null. See?
The null just means it's missing the data.
It's missing the data. It means that this customer number 125 doesn't have a sales rep number. And guess what? I can guarantee you, because there were 100 records in the first query and 122, that means there are 22 customers that have it missing.
Mm-hmm.
If you really want to see who's missing, you can write the where clause where sales rep employee number is null, right here. Okay. By the way, semicolon is important to put because it means that it's the end of the SQL statement. So we usually do that. Okay, so let's go to sales rep. Oh, sorry, this is the wrong field. Jeez, sorry. Okay, let's see, 22 records. Where's that employee number? Wait a minute, what did I do? Oh, look what, see what happened? So this is actually very good that it happened. We have semicolons in two places. Okay, when I ran this thing, it thought that I stopped here, right? Because this is the end of it. So you understand why it didn't show me what I wanted, because it ran wrong query. It never got to where clause. So now it's 22 records. See, it shows 22 records returned. Let's go to the sales, to the employee number, sorry. It's null. It means all of these customers, there are 22 customers that do not have employee number assigned to them, okay? Is this kind of clear?
Yeah, so if, you know, I wanted to look at employees that weren't entering their employee number or they weren't getting credit for something like that, I could look it up through that.
Yep.
Yeah, okay.
Absolutely. Okay. So the next one, I think there's the next query. I don't know, we can go on and on. I don't know what you want to focus on, but this is an example of a simple join or inner join, however you want to call it. We're looking for the customer number 339. That's all we do. And we want to see at all the customers and orders for the customer number 339. If we knew the name of the customer, we could put where, not the customer number 339, where the customer name is classic gift ideas, right? So depending on what you know. So in the where clause, you're looking for a specific information, right? For a specific customer, specific employees. So this is, you write an, oops, I don't know what happened. In the where clause, you write everything you need, your specifics, okay?
So if you're looking for one piece of information, you would run the
Yeah, where
query
was
with
it?
the where. Okay.
Yes, so this is customer number 339. We looked at every single order for that customer. If we want to look at specific orders, we can write that this information in the where clause, where order number, you could write where order number equals 10,183 or order number equals 10,0307. But easier to write when order number in, and then in brackets, put with commas every number you need. Okay, it's just
What is putting in brackets? How does that change the information that you get?
it doesn't change anything. It shows you that you can put in several. It's just if you have many numbers, you can put them in brackets and mention all of them with a comma.
Okay.
If you have one, you put equal. This is what you do if you have one number or one name. If you have more than one name or more than one number, you put in, and then in brackets with a comma, list them.
Okay.
Okay, next thing is we would like to know all about the products and product lines, right? So we have to join two tables together to see. So this is all about product in every detail possible. Every product and product line is here, okay?
Okay.
Next query would show us the customers with payments for a particular customer, again, number 339. So let's see what kind of payment that customer has done. So again, it's classic gift ideas, and let's see what payments is there. There is a payment, there's a check number, payment date, and an amount, okay? So this is just an example. Then next I have homework assignments for people. What I did, because I really like complexity, wouldn't scare me. I joined all of the tables together and I had the giant query. And I would choose the where clause I needed to pull any information I needed, you know? So you can join them all with one query and change only where clause. That way you don't ever have to think. You need one time, spend a lot of time joining all tables together, and then never think about the joins again. Change only the where clause based on the question you have from your business.
Okay.
Make sense?
I think so. Can you give me an example of when you would that would make it easier? When would you use that?
I will try to find. We're gonna skip to the. This wasn't some kind of home assignments that I gave people, but because I want to show you the one huge query. I don't remember where it is, but there is a query that joins all of these tables together, and we're skipping to very advanced levels. Sorry. I don't know where I had it. Okay, here we go, advanced homework. So this is how you would join all tables together. Okay. And remember I told you about this number 2,996?
Mm.
Here we go. If you join all of these tables together, you will get 2,996 as your biggest record.
Okay.
What we did though, in order to get to this number, we had to do a little change for the payment, because sometimes people pay, there are many payments. We had to look at the latest payment of the customer in order to come up with this number, because if we didn't do it, we would have more records. If you join all of them together, this is 12,015 records with the payments. So the lowest record is probably the payments the customer's done. So one of these tables has 15. So the payments has a little bit duplicate information. It's hard to explain without going deep into data. That's why I have it. I've shown the two queries. But for you to understand, to keep the same number of records, you need to really understand the aggregations of data. Where is the lowest level? Where is the lowest level of aggregation? Where is the highest level of aggregation? Because this payment table is tricky. What we do in this query, we look at the max table. So this is actually a good example for you. If you want to look at the max payment or min payment or sum or average, all of these functions, max, min, average, sum, it's called a function. Okay. You need to write this query, and at the end you need to from table, and then you need to do group by. What are you grouping it by? In this case, we're grouping it by a customer number, and our SQL, what it does, this is a bit complicated. I'm giving you a lot of information at once. You understand that this is usually not done in one lesson. But what group by does, it aggregates everything by the first column. So you write first column, that column needs to be in a group by. If it's customer number here, it's customer number there in a group by. You aggregate by group number. You actually make SQL go and find every single payment date and show you on the screen only the latest one, the max payment date, and show the biggest amount that you can see in that table, which is not the biggest, sorry, it's not the max, it's a sum, and summarize every amount that the person had in the payment table. So this is the group by, how it works. It's a lot of information, but I think if you know group by, if you know how to join tables, if you know how to write where clause, I think you'll be okay, because this is, for querying is more than enough, I think. And the most important thing for you when you get to your job is to know your data. You need to know your data, where it's stored, which tables. You need to join the tables. You need to write one query that joins all those tables. And then all you do is at the end here, instead of semicolon, you continue where customer number equals 331. And the whole thing, you will see every single record about this customer, about every single order, every single everything the customer bought, employees that assigned, and all of that information. So, but this could be too much for you. So,
yeah, I mean, like I was saying before, I from the job descriptions I've seen, it's basically, you know, a sales management or management type of role, and it basically said you need to be comfortable in pulling data from SQL in order to use that information to make decisions or convince people to, you know, go in that one certain direction versus another.
Know your data, and you might never need to join all tables. You might need to join 2 tables or even 1, I don't know. But you need to know your data. That's important. Oh, this is it. This is SQL.
Okay.
I don't know. Ask me any questions.
Well, I mean, it's something I think I just really need to practice doing. Do you have any suggestions on where I could go to you know, just practice doing things?
W3 schools. Let me show you. So here's a good site for learning SQL. Let's look. They have different tutorials. You need to choose SQL, learn SQL. And here it is. So they will give you, if you do select, they'll show you the theory, right? Select column 1, column 2 from table name. We just learned that. And then they'll give you this sample database, and you can try it yourself. You can literally try it yourself. Click on it, and it will run SQL. And there will be 91 records, and here are your records. Okay, so you can practice.
Okay.
And here we go. They'll show you the total number of records for your reference. Customers table has 91 records. See on the right, there's all this information. So if you want to run something else, you can go, what do you want to practice? Where clause? Here we go, where clause. You want to see all the customers in Mexico. Let's do that. Select stuff from customers where country equals Mexico. There are 5, number of records 5. Basically the same thing that you show on the MySQL workbench, the one I showed you, only that it's everything in the background done for you. You just run on a button and see the result. Okay. Is that what you were asking?
Yeah, I think so. I mean, it's something, you know, one of those things I just learned by doing more often. So I, you know, need to practice doing things, I think.
Yeah, and in the where clause, you can use and or, see, where condition 1 and condition 2 and condition 3. So there are different scenarios you can use.
Yeah.
For example, where country equals Germany and city equals Berlin. But honestly, I don't know why they did it, because you can just put with city equals Berlin, unless there are 2 Berlins in the world. I don't know.
Yeah.
But I wouldn't even put this, the one I highlighted.
Yeah.
I think it's useless. Anyway, they just wanted to show you that you can use and. So.
Yeah. Okay.
Okay, so that's about it. I think you are ready to practice yourself.